next question will work from exam 3. Had to do with the standardization of a base, sodium hydroxide rather. Potassium hydrogen phthalate, KHP, is often used to determine the more precise and exact concentration of a base like sodium hydroxide, because in this particular case with sodium hydroxide it reacts in a 1-to-1 ratio. So this is this acid and this is the base. So but when you look at this number, this is its true concentration. So you have to see how much sodium hydroxide would be weighed out to get this 3.21 molar concentration. So that's moles per liter, right? So in order to get that, this is your exact number you have right here, and you put that with your potassium hydrogen phthalate. So you wanted to figure out what mass of it you truly had to work with. So we'll take a look at that problem. So you'll remember we had from the previous part, we weighed out 67.5 grams of NaOH because we're using the previous problem's number, right? This mass refers to the previous one we did. So I just looked back and it was 67.5 grams. So that's what we figured we needed to weigh out. But then we standardize it. Basically we titrate it and use it in a titration and determine what its true concentration is. So this is what we used to get to the what we thought was 12.5% by mass solution. But we determined that it's this. So we also had in that problem a density. We had a density of 1.08 grams per milliliter. So that was the density of the solution, right? Then once we made it, and the concentration was 12.5%, we thought by mass, right? We thought it was that. That's what we intended to make, but we actually found out it was this. So 3.21 moles of NaOH per 1,000 milliliters of solution. That's what we really made. So if this is what we really made, then how many grams of sodium hydroxide did we actually get? Well, you know that this part right here, the number of moles per liter, is equal to your molarity, but moles and grams, you can use a molar mass. So you go to your periodic table, which I have one here in front of me. As I look at it, looks like sodium is 22.9898. I believe that's what it says. Anyway, oxygen is 15.9994. Hydrogen is 1.008. So I get that 1 mole of NaOH is 39.997 grams of NaOH. Just like so, if you made this amount, that you used, and from the previous problem, you made 500 milliliters of it, right? So this milliliter here needs to be canceled out. You made 500.0 prepared the solution was from the previous problem. And you cancel out that, and you're going to find out how many grams of sodium hydroxide you actually had. Now remember that sodium hydroxide is hygroscopic. That means when you're weighing it out, you're weighing out significant amounts of water as well. So I'm going to multiply straight across 3.21 times 39.997 times 500 divided by 1,000. 64.2. See that? So it's 64.2 grams actual sodium hydroxide. So this number's less than, which is what we'd expect, because you're not getting just pure sodium hydroxide when you weigh it out. So the true mass that you weighed out is 64.2 grams. The rest of it was water, right? So your other part here, if you look at that, the amount of water that you had was what, 3.3. So there were 3.3 grams of H2O, just I guess just water, water molecules that collect on there that you are weighing, but they don't count as sodium hydroxide, right? They obviously will affect your volume too when you make molar solutions. So that's why a lot of times molality is often used, because it's not affected at all by volume. Just it's all about mass and moles. So anyway, so your answer to this one would have been 64.2, as expected, less than what it was for what you actually thought you were going to have. So what that tells me is I actually made a less than a 12.5% solution. Not quite what I thought it was, because I didn't have as much sodium hydroxide as I thought I had. Okay? And we'll pick up with that one and take it a step, do another problem off of it here for the number 4.